Alright, so I'm gonna see if I can get this done again. I got muted a few times. I don't know why. Suspended animation. Cryogenics. It's basically a unified life support system. Now you want to keep the chamber above freezing to prevent tissue damage, about 33 to 36 degrees. It's Fahrenheit. It's about 2, maybe 3 degrees Celsius. Now blood contains salts, and it actually has a lot of minerals in it too, so it has a lower freezing point than fresh water. It's got the same pH as the ocean. So it'd be about 28 degrees Fahrenheit to freeze, or about negative 2.22 degrees Celsius. So this is about 8 degrees above the blood freezing. Now this is basically a sleeve that the person slides through that's like an iron lung. It's a pressurizer or a lung decompressor. This will basically breathe slowly for the person. And the computer measures the body temperature, the ambient temperature, the pressure inside the tank. It measures the brain waves, the oxygen, the heart, and basically your vitamins and your minerals. Now the oxygen here that the person is actually slowly breathing has to be cryogenic temperature, which is a very cold temperature, but not freezing. Again, you can't risk tissue damage, but it can't be room temperature. And there's a nutrient bag here that the computer controls, like I was saying, but it's not a hollow tank like an oxygen tank. It's actually got an electronic mechanism in it, and like nutrient bags are saline, vitamins, enzymes, hormones, and the computer controls this depending on the blood content. And there's 2 sensory cords here that run down the length of the person on each side, and it measures the body, the temperature. These are little sensory cups that are all over the body. And there's a brain cap here, and this measures the brain waves. The LCD screen is right here, which is basically it's the computer head unit. And the content of the body is read. The computer knows what it needs to do to inject certain minerals, vitamins, hormones, whatever it needs to keep the blood's consistency right. So basically what you're doing is you're freezing the person to death, but the computer prevents it, keeping them on the cusp. But a catheter is actually going to have to be installed before the process also, because they will actually need to urinate. Because despite this being a slow process, their body is still needing to filter out certain chemicals that build up in the blood after the liver and the body processes to get its minerals, even if it's directly in the blood. Now they'll need a strong tranquilizer for this process that's at least designed for the procedure. A good place to start would be like succinylcholine or something. It's a depolarizer of the muscles. It basically blocks neuromuscular signals, allowing the body to maintain a type of skeletal paralysis. That way you don't move or twitch you can't move around in this situation. Plus it also decays really slowly, because at this temperature in stasis, it'll decay over a long period of time. But at normal body temperature, metabolic, basically, it decays out of the system really fast. But when they're going under, it'll decay slowly, and it can, proportionate to the time, that's how much you give them over the dose, or the dose over the time. Now they're going to have to be injected or have glycerol into the blood and body, so it'll preserve the skin and increase the volume of blood. And this actually helps the liver produce glucose, which is food for the brain. Because you're not eating, your stomach is basically disabled, so your liver has to accommodate. The person will age, but they'll age really slow. The body will be around 36 to 40 degrees, and microshocks given to the heart and muscles to keep it from atrophying, and in case it's necessary if the person's having stress and their heart's wanting to give out, the heart can get microshocks to keep it going. So it'll squeeze real slow. This could be kept on as like a fail-safe, because some people actually have genetic accommodations for cold. Like that chick that froze to death, and she froze solid, and they thawed her out, and she came through it like a champ. The War's S2 gene, they found out it's what makes people cold tolerant. So they would probably come through this pretty well. Just throwing that out there. I'm just saying forms of gene therapy could be derived from these people's DNA, for this process, for people that aren't cold tolerant. Now, theoretically, and this is only with the static warp drive, because you're slowing your metabolic functions and increasing the speed of the craft, which will allow us to go 3.6 times the speed of light. And we're not going that fast, we're just tricking the clock. But back to this. They could theoretically remain in stasis for about 15 years, which are basically Earth years. But that's only over 2 ship months. And you have to revive them really slowly or they can go into shock. Basically, the chamber will warm fractions of degrees, and the lung compressor or decompressor will start picking up slowly, allowing for the person's circulation to start coming online very slowly. It'll take hours to revive a person, likely 6 to 8 hours, and their core temperature will slowly rise. And the computer, it'll inject minute amounts of noradrenaline whenever it gets within a certain range, like 95, 96, basically before your body temperature gets to about right. This helps induce the core temperature rise, and it'll trigger sweating because it'll induce your fight or flight. And once this mechanism is triggered, you're definitely going to want to live, But the last administration is going to have to be a type of sedative to keep the person from basically going into convulsions, because it's basically trying to induce chemical responses for homeostasis to take place. It's like a medically induced coma. It's not about having to be really, really cold. It's about how far off homeostasis you can go without dying and coming back from it. Now, the slowest heart rate ever maintained or that's actually been read is 27 beats per minute. And that's without this system. So I'm willing to bet, I'm just theoretically, the system would slow the heart rate down to 1 or 2 beats per minute. And the person ages proportionately to their heartbeats. The heart typically beats 1 beat per second, depending on how well someone can maintain their breathing to slow their heart rate. And just to clarify, the static warp drive doesn't travel the speed of light. It only travels 4.9 million miles per hour. The craft only travels at 4.9 million miles per hour. But by slowing the heart rate that much and traveling 4.9 million miles per hour, it takes us 5 years to get to Alpha Centauri instead of 900 years. It's basically 2,200 kilometers per second. Now, the tardigrade can go into stasis. It can survive real harsh environments. And by studying them, we found out that there's certain proteins that they use to go into stasis. And these proteins create gels inside the human cells, which slow the metabolic functions. So that would actually be a really good place to start, or some kind of solution could be derived of their DNA for this process.